Okay, we want to work on ideas of USA mathematical talent search. And these are the ideas. We will consider these ideas, 8 ideas, and I will leave 5 homeworks. We will work on one of the problems and last problems. We will solve it. I will consider these ideas step by step, and for each part, I will tell you related homeworks and you can learn. If you want to learn more background ideas, if you want to work on more homeworks, if you want to prepare for any exam related to math, for example, AMC, AME, use somehow, you can use my videos. And also, if you want to learn important ideas, 40, 50 important formulas and ideas in each topic, geometry that you should memorize, algebra, combinatorics, and number theory, feel free to send message to my WhatsApp number in the description comments if you want to prepare for important math exams, prestigious like I am or other math exam, any math exam for school. Okay, let's consider problems of round 1 of 2022, 2023. We have one problem, problem 2, problem 3, problem 4, and problem 5. Okay, let's focus on last problem here. It says what? Okay, it says we call a positive integer n. Positive integer n 6-ish if n equals p times p plus 6, where p and p plus 6 are prime numbers. For example, 187 is 6-ish because it's 11 times 17. Both of them are prime. But 475 is not 6-ish because it is 19 times 25. The difference is 6p times p plus 6. But why it's not 6-ish? Because of 25. 25 is not prime. It says both p and p plus 6 should be prime. Define function f on positive integers such that f of n is the sum of the squares of the positive divisors of n. For example, f of n equals the divisors of 10 is what? 1, 2, 5, 10. Sum of their squares equals 1 squared plus 2 squared plus 5 squared plus 10 squared, which is 130. Part A. Find with proof an irreducible polynomial function g of x with integer coefficients. Okay, coefficients should be integer and irreducible, such that f of n equals g of n for all 6-ish n. Reducible means that g of x cannot be factored as the product of two polynomials of a smaller degree with integer coefficient. Means prime numbers, it should be in polynomial, it should be prime. Something like this. You cannot factorize it as two other polynomials with degree that their degree are at least 1. So when the degree of both of them at least 1, the degree of them will be smaller than the main degree. Okay. Let's work on part A. It says f of n equals g of n for all 6-ish. For all 6-ish, so suppose n equals p times p plus 6, and it is 6-ish. F of n by the definition is what? Let's write the divisors. It is 1, it is p plus 6, and p times p plus 6, which is n. Because we want to write f of n as a polynomial in terms of g of n, we write p times p plus 6. We can write it here as p times p plus 6, but we should replace it with n. So it is what? It is 1 squared plus p squared plus p plus 6 squared plus p times p plus 6 whole squared. Okay. Now, because of this, I want to write it like g of n polynomial in terms of n, not p. So let's see how can I write it in terms of n. This one is n, so let's write 1 plus p squared. Let's also expand this. We know that a plus b squared is a squared plus 2 times p times 6, 12p plus 36 plus n squared. Okay. So p squared plus p squared is what? Is 2p squared plus 12p plus n squared plus 1 plus 36 is 37. Okay. Now we can factor from 2p. It will be 2p p plus 6 plus n squared plus 37. P times P plus 60 is what is n? So it is 2n plus n squared plus 37. So if we write in a decreasing order of degrees, n squared plus 2n plus 37. So we found this. Now we should prove that y we cannot factorize this. Y it is irreducible. So we found g of n. I define g of n equals this. So let's see why it's not irreducible. G of n equals n squared plus 2n plus 37. If it is not irreducible, means it is reducible, and for example, it is n plus a, n plus b with integer coefficient. Why the coefficient of n is 1? Because it is n squared. If one of them is -1, you can multiply by -1, -1, both of them. Then it will be 1, 1. So without loss of generality, we can consider coefficient of n is 1. Okay? Now, here it is what? It is n squared plus n times a plus b plus ab. So if these two things are equal, 2 equals a plus b, 37 equals ab. So let's write, and a and b are integers. ab equals 37, a plus b equals 2. From here, because a and b are integers, the cases of b. 137, 37, 1. -1, -37, -37, -1. And we know a plus b should be what? Should be 2. In first case, it is 38, 38, contradiction, contradiction, -38, -38. Again, contradiction. So we proved that we use contradiction for irreducible, okay? If it is reducible, we reach contradiction. So g of n is an irreducible polynomial. Okay, so we've solved part A. Now let's focus on part B. Okay, so here we've only written the divisors, and after that I will tell you some problems similar to divisors. If you want to work more on divisors, something similar to this, as I said before, feel free to send message to my WhatsApp number in the description comments to learn these background ideas. Okay, part B. We call a positive integer n pseudo-six-ish if n is not six-ish. It's not six-ish, but nonetheless, f of n equals g of n. Okay. Where g of n is a polynomial function that you found in part A. Find with proof all pseudo-six-ish positive integers. Okay. In this part, I want to tell you an idea, that this idea is also useful in SUMAC. SUMAC is summer camp for Stanford. And I will tell you the problem. The structure of proof is exactly same. We have also same proof in AMC and in many other exams. Also in Promise, it's another prestigious summer camps. In many problems, we have this idea. So let me tell you, background idea is what? Then we try to solve this, and I will leave these problems as homeworks. And let me tell you, for part A, idea 1 that I will explain is related to divisors. You should know these things. Number of positive divisors, sum of positive divisors, which is so much useful in AMC. Product of positive divisors. And rainbow idea in divisors. Let me add a page. Let me write. Rainbow or Gauss idea of positive divisors. We have some ideas like this. And for example, the ideas in GCD, that greatest common divisors. We have lots of ideas in I1, idea number 1. And I will explain some of them for you. And if you want to learn completely the ideas, and I will tell you a problem from IMO, you can solve from, as I said, promise, from these things, you can solve with this idea. If you want to learn this idea completely and other ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, let me tell you some of these things. If n is p1 alpha 1 to pk alpha k, number of positive divisors equal alpha 1 plus 1 because power of p1 can be 0, 1 to alpha 1. Alpha 2 plus 1, I want to explain these things briefly. If you want to have more explanation, as I said, you can send message. Sum of positive divisors is 1 plus p1, p1 to the alpha 1 up to 1 plus pk to pk alpha k. And product of positive divisors, you can use rainbow Gauss idea in this one, also in IMO problem, IMO 2023. You can use this idea. It is what? It is when you write 1, the next divisor is n. For example, when you write p, the next one is n over. When you write d, the next one is n over. This one, 1 and n, and this one and this one, the product is n. So when we want to solve product of positive divisors, if we call this one t, you can use this rainbow idea and prove it is n to the t over 2. Okay? If you wanted to know the proof of them or explanation, you can send message now. Also, we have GCD. Let me tell you two problems that you can solve. So I think number sum product, all ideas we can say in product, in divisors. So let's do something. Let's define because we've separated them. The idea here we use idea 2, idea 3. The idea here we have rainbow idea, so 4 ideas. Let me tell you the first homework as promise 2022 that you can solve the problem. Okay, so try this problem as homework. Okay. It is related to divisors. And if you had questions, send message to my WhatsApp number. It was related to this homework too. Is IMO 2023. Let me show you the problem. Okay, the problem is this. Let me open it. 2023. This problem related to divisors. Okay. I also released the solution of this. You can use my solution in my channel. It's first problem of IMO 2023. Okay, problem number 1. So we have two homeworks related to divisors. And now let's focus on part B. Now, here we've written 4 ideas. Fifth idea is structure of n, which is consider prime factorization of that. And for prime factorization, you should combine this idea with small examples. But a small example on what? It is so much important. Small examples. Here, when you want to use the small examples, for example, you should consider first number of primes, then power of primes. Okay, for example, here. I consider first we have 1 prime. We have only p. Okay, so suppose if n equals first, let's consider 1 prime, then we consider 2 prime. So now that we considered 1 prime, let's consider first p to the 1. Then we will find the idea and solve the problem. This idea useful in SUMAC, in hard problems of AMC and also other exams. So let's focus on p. G of n was what? N squared plus 2n plus 37. Okay? Okay, so let's write g to the n. Sorry, g of n is n squared plus 2n plus 37. Now we want to see is it equal to that or not. So for prime number, f of p is what? The divisors. 1 squared sum of square of divisors plus p squared. Is it equal to p squared plus 2p plus 31? No. Why? Because we cancel this. 1 equals 2p plus 37. If you subtract 1 from both sides, 0 equals 2p plus 36. But p is a positive prime number, and it cannot be 2 times that plus 36 is positive, not 0. If, for example, we have, let's consider p to the k. Let's see, can we prove p to the k? If we couldn't, then we try p squared, p cubed to find the idea. F of p to the k is what? Is 1 squared plus p squared squared the primes, the divisors, up to p to the k squared equals n squared plus 2n. N is what here is pk. P to the k squared plus 2pk plus 37. Okay. Now, if we can cancel these two things. So we can also subtract 1 from both sides. So it will be p squared plus p to the 4 plus p to the k minus 1 squared, which is p to the 2k minus 2. And here we know k is at least 2 because we've considered k1. Equals 2pk plus 36. Okay. Okay, here let's consider some small cases. For example, if k is 2, it will be what? P squared 224 minus 2. P squared on left hand side. Right hand side 2p squared plus 36. So if we subtract 0 equals, if we subtract p squared from both sides, it will be 0 equals p squared plus 36, which is not possible because right hand side is positive. If k is 3, left hand side will be p squared plus last one is 6 minus 2, 4 plus p to the 4 equals 2p cubed plus 36. Let's write a new page. Okay, so here, one thing that we can consider, p squared divides this, p squared divides this, p squared divides this. So if something divides all terms except one, p squared also divides that term. Why? Because 36, if you take all things to left hand side except 36, so left hand side is multiple of p squared because all terms are multiple of p squared. So p squared divides 36. 36 is what? Is 4 times 9. So we can conclude p can only be 2 or 3. So here, if p is 2, left hand side is 2 squared 4 plus 16 equals 2 times 8, 16 plus 36. Okay, left side is 20, right side is greater than 20. If p is 3, right side will be 46, 52. If p is 3, 3 squared is 9, 3 to the 4th is 81. 2 times 27 is 54 plus 36. Oh, we found a good number. This one is 90. This one, 54 plus 36 is also 90. So we found 3 and K3. So the first number is N3 cubed, which is 27. This number is not product of two primes with different 6, but it satisfies f of n equals g of n, so it is pseudo-six-ish. Let's check to make sure. The divisors are 1, 3, 9, 27. We want to put 1 squared plus 3 squared plus 9 squared plus 27 squared equals g of n is what? N squared 27 squared plus 2 times 27, 2n plus 37. Okay, so we can cancel this. This one is 54. This one 81. This one 9. This one 1. 91. This one also 80, 91. Okay, so we've checked again because maybe we had careless mistake. Always when it takes time you reach some good thing, try to check in 1 minute. Then if you have careless mistake, you will understand. Okay, so P3 works. Now we've considered K2 and K3. Let's consider for general case. See, can we consider good thing? Okay, here again we can say p squared divides this, divides this, divides this, and we've considered up to k3, so here we can say k is at least 4. Now p squared also divides this because k to the 4 is k is at least 4. So we can conclude again p squared divides 36. 36 is 4 times 9. So we can conclude p is 2 or 3. Let's consider p2 first. 2 squared plus 2 to the 4. plus 2 to the 2k minus 2 equals 2 times 2 to the k plus 36. Okay. So you should know an identity. Let me tell you, we have some important identities. I7, let me tell you, the identity here we need is 1 plus r squared to r to the n. You can write it as r to the n plus 1 minus r minus 1. Or we can write 1 minus rn plus 1, 1 minus r. Okay, I want to use it here. And we have also another identity, stochastic van der Monde's identity. And triangular form, lots of identities. If you want to learn the others, as I said before, feel free to send message to my WhatsApp number in the description comments. Here we can factor from 4 to squared. It will be 1 here. This one will be 2 squared or 4. The next one is 4 squared. And last one, this one is 4 to the k minus 1 because we factor from 4 to the k minus 2. Okay, here it will be 2 to the k plus 1 plus 36. Now we divide both sides by 4, so 1 plus 4 squared to 4 to the k minus 2. If we divide by 4 is 2 to the k minus 1 plus 9. Okay, now if you check this, if you use this formula, it will be 4 to the k minus 1 over 3 equals 2 to the k minus 1 plus 9. So if we multiply, 4 to the k minus 1 equals 3 times 2 to the k minus 1 plus 27. Okay, now we add negative 1 to right side. 4 to the k minus 1 equals 3 times 2 to the k minus 1 plus 28. Now we divide both sides by 4. It will be 4 to the k minus 2 equals 3 times 2 to the k minus 4 is 2 squared, k minus 3. And we know k is at least 4, okay? So we can divide it, and it will be integer plus 7. Now this number, because k is at least 4, this number even. This number k is at least 4 even, but this number odd. Even plus odd is odd, so that's a contradiction. So for 2, we've reached contradiction. Let's consider p. We've considered we've considered p equals 2. Let's consider p equals 3. Okay, here let's consider p equals 3, then 3 squared plus 3 to the 4. 3 to the 2k minus 2 equals 2 times 3 to the k plus 36. Okay. This one is 9 plus 9 squared to 9 to the k minus 1 equals 2 times 3 to the k plus 36. Now we know k is at least 4. Okay, here we said we've checked k1 to 3. Now we can divide both sides by 9 because 3 to the k is also a multiple of 9. This is 1 plus 9 to 9 to the k minus 2 equals 2 times 3 to the k minus 2 plus 4. Now here we can subtract 1, or we can use the identity, or we can solve this other ways. If we subtract 1 from both sides, it will be 3. Now, all these numbers are multiple of 9. 9 divides this because k is at least 4. 9 divides this, but 9 doesn't divide 3. So that's a contradiction. Now let's see for here, for 3 to the something, we prove for k3. Let's check, is it correct? If k3, it will be 9 plus 9 to the 1. Oh, okay, so it will be 9. Right side will be 2 times 3 plus 3. Oh, it is correct for k2. But here, because k was at least 4, we could reach contradiction. So for p to the something, we've proved our only number is 3 cubed. Okay, now in next case, we can consider k. We said p to the k, so let's correct something. Here, we said we have 1 prime. Okay, it was p to the k. Well, let's consider we have 2 primes, okay? P1 to the alpha 1 p2 to the alpha 2. Now, how many divisors do we have? And as you can see in previous case, we will see left side was so much greater than right side because it's 9 to the k minus 2, 3. So we understand when we have more divisors, it seems that f of n, sum of the squares of divisors, will be greater than g of n. So when we have product of two primes, so the number of divisors will be at least what? Number of positive divisors. It is equal to alpha 1 plus 1, alpha 2 plus, which is at least 4. So when we have 1 and n, if we consider the minimum divisor, it is a prime p. This one is n over p. Maybe also we have some other numbers. And f of n is at least 1 plus p squared plus n over p squared plus n squared. And we know that f of n equals g of n. Okay. Why I say at least? Because maybe we have some other divisors, but we have at least 4 divisors because of this. So when we consider the prime minimum divisor, n over p is the maximum divisor after n. And they are different because if p equals n over p, then we have 3 divisors. Okay. G of n was what? Was n squared plus 2n plus 37. If we cancel n squared, as you can see, it seems that this part should be greater and we can reach contradiction. So let's consider this part. Maybe for only some special cases they can be equal. So 2n plus 37 is greater. Let's subtract 1 from both sides. 2n plus 36 is greater than equal p squared plus n over p whole squared. So we can do something. We can consider 36 and we can take 2n to right hand side, n over p whole squared minus 2n. You can write it this one as perfect square. Try. It is p minus n, because n over p is greater. Let's write n over p, but both of them are correct. And here is positive. N over p minus p, because this is squared plus this is squared minus 2 times the product. Now we can conclude this is less than or equal 36. So n over p minus p then it is positive. It's less than or equal 6 and greater than equal 1. And here if we analyze this one, it will be 6 plus p. Let's consider this side. We add p to both sides and then we multiply by p. N is at most p times p plus 6. And interesting thing, these numbers are 6-ish numbers. So n is at most p times p plus 6 if p is the smallest prime. Now one important thing, p was what? The smallest prime that divides n. Okay, we said first prime. So p plus 6, if p plus 6 is prime, then it is 6-ish number. Okay, so we consider two cases. If p plus 6 is prime, then we can conclude what? I think it's better to do another thing. Look, here, do you agree we said that n over p here is less than p plus 6, okay? And we know n over p is greater than p, so it is at least p plus 1. So we conclude n over p can be what numbers? P plus 1, or p plus 2, or p plus 3, or p plus 4, or p plus 5, or p plus 6. Okay, we have these 6 cases. Okay, now we consider 2 cases. P is the smallest prime. We consider p is 2 or p is not 2. Because when p is not 2, p is odd. And the smallest prime is odd. And then this divisor cannot be even. We can reject many of them. So let me explain. Okay, so case 1. If p is 2. If p is 2, we can find n is what in the cases? N is p times p plus 1, 2 times 3, 6, or 2 times 4, 8, or 2 times 5, 10, or 12, or 14, or 16. Okay? We can consider these cases. So, f of n is what for 6? So let's consider f of 6 first. Is 1 squared plus 2 squared plus 3 squared plus 6 squared. We know g of n was what? N squared plus 2n plus 37. Okay. So g of 6 is what? Is 6 squared plus 2 times 6, 12 plus 37. 6 squared will be cancelled. Left side is 1 plus 4 plus 9. Right side is 49. But obviously they are not equal. F of 8, if we check, is 1 squared plus 2 squared plus 4 squared. In 1 prime we've considered f of p to the something, so we don't need to consider 8. Let's consider f of 10 is 1 squared plus 2 squared plus 5 squared plus 10 squared. It should be equal to g of n. Let's check 10 squared plus 20 plus 37. We want to check which of them, for which of them f of n equals g of n. 10 squared will be cancelled. Left hand side is 1 plus 4 plus 25, which is 30. Right side is 57. Again, contradiction. F of 12 is what? Is 1 squared plus 2 squared plus 3 squared plus 4 squared plus 6 squared plus 12 squared equals 12 squared plus 2 times 12, 24 plus 37. 12 squared will be cancelled. This one is 36. Let's write 36, 16, 9, 4, 1. Okay, so 1 plus 9, 10, 14, 30, 66. And this one is 1, 50, 61. Contribution again. Two numbers all left. We don't need to check 16 because it is 2 to the something. In previous case, we've considered f of 14 is 1 squared plus 2 squared plus 7 squared plus 14 squared. And if you check with g of n, it is 14 squared plus 28 plus 37. 14 squared will be cancelled. It will be 1 plus 4 plus 49 equals 28 plus 37, 5, 65. So 554. Okay. So that's a contradiction of a fourth. Now p is not 2, so p is odd. Okay. Okay, we know the divisors are 1, the smallest one p, like greatest one n over p, and p. P is odd. So n is, for example, p times p plus 1, because p plus 1 is even. So we consider the smallest prime that divides n is 2. We've considered that. Similarly, we can p plus 3 even, because n cannot be even then. Because the smallest prime that divides that is odd. So we have these cases. N equals p times p plus 2. And p is the smallest prime. N equals p times p plus 4. And n equals p times p plus 6. Now, one case. I want to say p plus 2 is a prime number. Why? If p plus 2 is not prime, then we can say what? We can say p plus 2 is ab. And I want to prove, and at least product of two divisors, which a and b are greater than 1. Because the smallest divisor of n, a and b are also divisor of n, because divisors of p plus 2 divisors of n. But the smallest divisor greater than 1 is p, and a and b we know are not p. Why? Because if, for example, a equals p, or if p divides a, we know a divides p plus 2. So p divides p plus 2, p divides p, and then p divides 2. That's a contradiction. Okay, so a and b are relatively prime with p, so a and b are greater than p. Okay? And now we can conclude what? We can conclude that p plus 2 is product of two numbers greater than p. A and b, both of them greater than p squared. And we know it is wrong. Why? Because p squared is greater than p. Because it's 2 greater than p squared minus p. It is p times p minus 1. P is odd. We know p is at least 3. This one is at least 2. Because p is odd, at least 3. This one at least 2. This one is at least 6. 2 is greater than 6, contradiction. So we've reached contradiction for first case. Try to reach contradiction for second and third case on your own first. Let's analyze second case, p plus 4. Again, if we have something like this, if p plus 4. Sorry. Here I proved that p and p plus 2 is prime, okay? So we should consider if p, now we can conclude p plus 2 is prime, and n equals p times p plus 2. Now, because p and p plus 2 are primes, then f of n equals, the divisors are what? 1p, p plus 2, and p times p plus 2, or n. It is 1 squared plus p squared plus p plus 2 squared plus n squared equals to g of n, which is n squared plus 2n plus 37. N squared will be cancelled, and here it will be 1 plus p squared plus p squared plus 4p plus 4 equals 2 times n. N is what? P times p plus 2, which is p squared plus 2p plus 37. So we can cancel p squared, and we can subtract 1, 4, 5 from 37, 32. We can say p squared, we can subtract 2p from both sides, plus 2p equals 32. Okay, so it is p times p plus 2 is 32. It's on p and p plus 2, or n equals 32. But it's not possible. Why? Because n is product of two different primes, p and p plus 2, but 32 is 2 to the 5. So here we reached contradiction. Now let's consider this case. For this case, again, you can say if p plus 4 is not prime, we can say same thing. So p plus 4 is product of two things, and p and p plus 4 don't have any common divisor because p is odd. Their divisor divides the difference. D divides 4. And also, let me tell you another idea. I've told you up to I7, I8. It's important to learn how to work on, for example, GCD of A and B. We have some rules. For example, you consider D divides A, D divides B, working with probabilities. So similarly, we can say p plus 4 is greater than p plus 1. The numbers greater, A and B are greater than p. You can say at least p plus 1 times p plus 1. So it's easier to work with instead of writing greater than, strictly greater than p squared. So both of them are correct. You can reach contradiction with both ways. But in this way, you say, okay, p squared plus p is less than or equal to 3. It is p times p plus 1. P is at least 3, so it's at least 3 times 4, 6, 12. Contradiction, so we can conclude p plus 4 is prime. And then you say, okay, let me write with another color. Okay, so 1 squared plus p squared plus p plus 4 squared. N is what? N is p times p plus 4, and both of them are primes. P plus 4 squared is f of n plus n squared. G of n is what? N squared plus 2n plus 37. So if we cancel this and this, it will be 1 plus p squared plus 8p plus 16 equals 2 times n. 2p squared plus 8p plus 37. So 2p squared, 8p, 17 equals 37, which is contradiction. One case is left. Again, let's focus on this part. Okay, now I want to consider p plus 6. If p plus 6 again is not prime. If it is prime, then it is 6-ish number. If it is not prime, then we consider GCD of p and p plus 6, for example, equals d. So d divides p plus 6. D divides the difference, 6. But we know d divides p is odd. So d is also odd because it is a divisor of that. D divides 3. So d is 3 or 1. Okay, if it is 3, case 1. If d equals 3, then 3 divides p. And p is a prime, so p is 3. And p plus 6 is what? Is 9. So n is what? N is 27. So we've considered this number 3 cubed, okay? That it works. Case 2d is 1. Suppose they don't have any relative prime. If p plus 6 is not prime, p plus 6 again we can say is ab. And we know the smallest prime is this, then n, then p plus 6. So you can write p plus 6 as product of two numbers greater than equal p because they don't have any common divisor with p. Their GCD is 1. They are relatively prime. It is again at least p plus 1, p plus 1. So it is p squared plus 2p plus 1. So if we subtract p, 6 minus 1, 5. P squared plus p. This is p times p plus 1. It is at least 3. 3 times 4, 12. It is at least 12, which is contradiction. Okay. And if p plus 6 is prime, then it is a 6-ish number. And the problem says we want to find numbers that are not 6-ish, pseudo-6-ish. Okay, so we proved our only number that works is 27. Let me tell you other homeworks I wanted to say. Okay, I've told you how many ideas? 8 ideas. Okay, and let's see how many homeworks do we have. I've told you some homeworks. Homework 2. Okay, for this structure working with primes and considering special cases, homework 3 is SUMAC 2022. Okay, this one is for Stanford summer camp. You can try this problem exactly. You can solve with same proof. Homework 4 is from AMC. You can try this one with the idea I've told you. Homework 4. Homework 5. We have also another AMC problem. Let me tell you. Okay, this problem of AMC 12A 2021, last problem, is useful. 12A 2021. Let me write it here. 12A 2021. Problem 25. You can solve this problem with exactly the idea I've told you. If you wanted to solve more homeworks or wanted to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. So in these parts, we have 5 homeworks. And how many ideas? I've written 8 ideas. Okay, 8 ideas. We have also more ideas. We have 40, 50 important formulas you should memorize. We have also, and it will be updated, okay? After some weeks, we will, for example, some exams, the problem of some exams will be released and we will find another important ideas and we can complete our list. If you want to know that list, as I said, you can send message to my WhatsApp number. Okay, thanks.